The universe is vast, unimaginably so. Within this cosmic ocean, our own civilization is just a tiny, fleeting ripple on a distant shore. But we are a curious species. We look up at the night sky and we wonder, are we alone? This question has echoed through human history, driving our stories, philosophies, and our science. For centuries, we imagined little green men in flying saucers. But what if a truly advanced civilization left a much bigger sign? What if they built something so colossal it could be seen across the light years? These are megastructures, vast artificial constructions around a star to harness its energy. Imagine a civilization far older and more technologically advanced than our own. Their energy needs would be astronomical, beyond what a single planet could provide. They might build a Dyson sphere, a swarm of orbiting power plants, enormous habitats, ring worlds, stellar engines to move their entire solar system. These ideas come from physics and science fiction, but they're not just fantasy. They could be the next step for a civilization that has mastered its cosmic neighborhood. Finding one would be the single greatest discovery in human history. Out in the constellation, Cygnus the Swan, about 1,470 light-years from Earth, there's a star. It's a bit more massive and hotter than our Sun. It was one of billions in our galaxy. Its official name is KIC 8462852, but we call it Tabby's star, named for Tabitha Boyajian, who led the team that first studied it. This star wasn't behaving like any other we'd seen. The Kepler Space Telescope had been watching it for years and the data was baffling. It was dimming, not in any predictable way. Normally a planet transit produces about a 1% dip, and it repeats like clockwork. But Tabby's star was different. The starlight would plummet, sometimes by as much as 22%. That's an enormous block of light. Whatever caused it had to be huge. The dimming events were erratic. They happened at random intervals and lasted for different lengths of time. Days, weeks. When faced with a mystery as profound as Tabby's star, science doesn't jump to conclusions. It gets to work. The first step is to brainstorm every possible explanation, the mundane, the extraordinary, and the list for Tabby's star was long. Could it be a problem with the Kepler telescope itself? That was checked and quickly ruled out. Other stars in the same field showed no such behavior. Could it be instability inside the star, making it pulsate or flicker? That was investigated. The spectral type suggested it should be stable, and the dimming didn't match known variable stars. Astronomers then looked to the space around the star. Perhaps a vast cloud of dust and gas was orbiting it, but that dust would heat up and glow in infrared. Early infrared observations showed no expected excess. What about comets? Maybe a massive swarm of comets knocked from the outer system passed in front of the star. That made comets a leading natural explanation. Irregular shapes and orbits can make chaotic dimming. Then came the most speculative hypothesis. What if something artificial was causing the dimming? Astronomer Jason Wright proposed this idea as a possibility to test, not a certainty. SETI even aimed powerful radio telescopes at the star, listening for signals. Science follows Occam's razor. The simplest explanation is usually best. But science tests all plausible hypotheses, even wild ones. The investigation into Tabby's star deepened. To solve the mystery, scientists needed more data across the entire spectrum of light. If a solid, opaque object like an alien megastructure caused the dimming, it would block all colors equally. Blue light, red light, ultraviolet light. However, if something translucent like fine dust caused it, it would behave differently. Tiny dust scatters shorter wavelengths. Blue, more than longer. Red. Same reason our sky is blue and sunsets are red. Ground-based telescopes watched Tabby's star for the next big dimming. When it happened, they measured the starlight in different colors simultaneously. The star dimmed more in blue than red. That was the smoking gun. The pattern didn't match a solid, engineered object. A megastructure would be like a rock in front of a flashlight, blocking all light. Instead, it looked like smoke or haze. That pointed strongly to dust, vast, uneven clouds of microscopic particles. The leading hypothesis, aftermath of a cosmic cataclysm, a swarm of giant comets disintegrating, or two planets colliding into dusty debris. The exact scenario is debated, but the culprit is almost certainly dust. The story of Tabby's star is a beautiful example of science in action. It's a story of observation, curiosity, skepticism, collaboration. It begins with a strange signal from the darkness, something that doesn't fit our models of the universe. This is where the real adventure starts. Instead of ignoring the anomaly, science embraces it. We ask questions, we challenge our own assumptions. We imagine possibilities mundane, magnificent. The scientific method isn't a rigid set of rules, it's a mindset that lets us navigate the unknown. We didn't find aliens at Tabby's star, but what we did find is just as important. We found a new and extreme kind of cosmic phenomenon. We learned that dust clouds around a star can be far more complex and dramatic than we previously imagined. So keep looking up, stay curious, the search continues.